Hey guys, this is the third video in our series on electrochemistry. Just to review what we did the last time, we found that by pairing lead 2 positive ion with calcium solid gives us a spontaneous reaction or transfer of electrons, ultimately because the oxidation reaction paired with the reduction reaction gives us an overall positive voltage potential. Now, one of the things we learned was that you cannot write both of the reactions from the perspective of reduction. You have to reverse the direction of one of these reactions. Imagine, however, had we written it the other direction. Imagine if we had the calcium 2 positive and the lead solid as the reactants, and the lead 2 plus aqueous and calcium solid as the products. In essence, had we reversed this reaction, both of these signs would have been reversed. You'd have a positive 0.13 and a negative 0.287, resulting in a negative voltage. When you have a negative voltage, you in fact do not have a battery. It is non-spontaneous, and you would get nothing happening. In essence, the lead and the calcium are competing for who wants the electrons more. And if you pair them in the wrong way, the non-spontaneous way, the substance which already has the electrons and wants them more keeps them. The only time you get a battery would be if you pair two substances together in a way that one wants them more than the other, the electrons, and you provide a path for those electrons to follow. This, of course, would happen in a beaker alone, without any wires, if we allowed these two things to touch. But what we do in a battery is we separate them into chambers, not allowing them to touch, but connecting these two substances with a wire. What that does is cause the electrons to flow through the wire, creating electricity. When electrons flow through the wire, we can then use them to do work. Notice here that the spontaneity of a reaction is linked to the voltage potential. The voltage potential is positive, resulting, when the voltage is positive, because there is a negative here, negative times a positive results in a negative delta G, which we've already learned is spontaneous. N refers to the moles of electrons exchanged in the reaction. In our previous example, we had 2 electrons exchanged, so N in this case would be 2. F is Faraday's constant, and Faraday's constant is 96,500 coulombs per mole. That is, a whole mole of electrons carries this many coulombs of charge, 96,500. This number never changes. This is the number you always plug in here. So what we have to do is find our voltage potential, as well as monitor the number of electrons in our balanced chemical reaction. Notice that if you had a negative voltage potential, negative times negative results in a positive delta G, which is non-spontaneous. Let's take a quick look at this reaction here. How did this number come about? If I were you, I would pause the video right now and see if you can use the page or the voltage potentials on the previous page to come up with this number. Go ahead and press pause. Welcome back. Let's see if you got this right. In this case, zinc is clearly going from the neutral to the ionic form. We look on the previous page and realize that this particular process is opposite of how it's shown here. We find zinc and we find a negative 0.76 voltage in this direction, so we have to reverse that number. The silver, on the other hand, is clearly gaining electrons because it's going from positive to neutral. One of the things I notice also is that, let's see, the silver plus 1 electron, giving us 0.80. The electrons, I notice, are out of balance. In order to do this correctly, I must multiply everything in the second equation by the number 2. However, in contrast to things we've done in the past, this does not get multiplied by 2. The voltage associated with the reduction potential is independent of the moles of that substance. It is an inherent quality, and it is an inherent pull of electrons of the substance that is independent of amount. So therefore, this number never gets multiplied by 2, divided by 2, or changed in any way. Let me double check to make sure I have everything right. Positive 0.76, positive 0.80. The voltage associated with this particular reaction, therefore, would be these two numbers added up, which would be 1.56 volts positive. This would be something that we could use for a battery. We could pair the zinc with a silver ion. The resulting battery would produce 1.56 volts. Again, let's review. We do not multiply the voltage when we are adding these up, even though we need to get the balanced chemical equation. The number of electrons lost always has to equal the number of electrons gained for a chemical reaction.